Hello everyone, good afternoon. Welcome to the class ECE341. Today we will keep working on the pairs of random variables. So let's finish the example of last time. ECE341. This is for the lecture for the next week, Wednesday's class. Okay, the example of last time, we have let me put the problem. We have two random variables, x and y. They have PDF fx y of xy equal to k times x times y if both x and y are between 0 and 2, and it's 0 otherwise. Right, so this one. And then we try to find what is k. Actually, we get this is 1/4, right? We get k is 1/4. And the second question is we want to find the marginal PDF fx of x and fy of y. We want to find these two. Actually, we have obtained fx of x is 1/2 of x if x is between 0 and 2. And is this correct? Yeah. And it's 0 if otherwise. Otherwise, that means x larger than 2 or smaller than 0. And this is let me check the notes of last time. Is this correct? This is xy over, this is x over 2. Yeah, x over 2. And we also have fy of y, which is half of y if 0 smaller than x smaller than 2 and 0 otherwise. Alright. And the third question, we want to find the probability of the event x plus y smaller than 1. And we get these is 1/96. 1/96, yeah. Okay, so we already have these. And furthermore, we also have, based on the second, by 2, we have the independent things. By 2, fy of y times this one times this one equal to the original joint CDF, right? So we know x, y, they are independent. Right, we have these. Okay, now we have one problem we left. We want to know those special average values. So this is the fourth. Find the EXEY variance of x of variance of y and the covariance of x and y. We want to find these 5 things. Then so EX, because we already have these fx, so we can just apply fx. We can also use this directly. This result should be same. We can work in both. Alright. So fx, the method 1, it is integration of x times fx of x from negative to positive infinity dx. Okay. This is the definition. If you only consider one variable x, then you just use this formula. Now we know x is just x. Fx is here. It's half of x, right? It's half of x when x runs from 0 to 2. Otherwise, it will be 0. So we have this one. We have this result. So this gives us 0 to 2, 1/2 x squared dx. So it is 1/2 times x squared. Then by integral we have x cubed over 3, and x run from 0 to 2. So this is a 1/6, right? 1/6, and x cubed is 2 cubed minus 0 cubed. Okay, 0 cubed is still 0. This is 8, so it's just 8 over 6. 8 over 6, which is 4 over 3. There will be 1.33 something, like this. So this is first method. We can also use the method with two integral, negative to positive infinite, negative to positive infinite. X is still x, but the density, I use the density of both x and y. And here will be dx, dy, like this. Okay, so this one, we know the density function will be 0 if x is smaller than 0 or larger than 2. Only when x, y belong to the interval from 0 to 2, it is non-zero. So the integration just 0 to 2, 0 to 2. And I use dx firstly. This is x times fxy is k times xy, and the dx, right, dx, then dy. Okay, so this is 0 to 2, k is 1/4. When you do this integral, y is nothing, it's not related with x, right? So you just move x outside, y outside. Then you have x squared, that will be x cubed over 3. And x round from 0 to 2. We got this one. And 0 to 2, 1/4 y, and 1/3 times x cubed. X cubed now is 2 cubed. 2 cubed. 2 cubed is 8. And minus 0 cubed. Okay, dy. So I can cancel these two, I get 2. So it's a 2/3 times the integral of this y, right? So I have y squared over 2, and y run from 0 to 2. So it is, this 2 cancel. Denominator only 3. And the numerator will be 2 squared minus 0 squared. Okay, so it is 2 squared is 4. 0 squared is still 0. So it's 4 over 3. Alright. Is it good? Now in both methods we have same result, right? In both methods we have same result. You can try to use this distribution just for x. You can also use the distribution for the whole, for both x and y. And the result will be same. Okay, this is ex. And then ey. Actually, ey, you check the density function, it is exactly, you can say it's the same with x. If you give a graph, it looks like this. This is also like this, right? They're same thing. Same thing. Just the variable, here's x, here's y. They change the letter. You can have different letter, but the graph, the waveform of the graph is totally same. Then you take average, you take a mean. You want the expectation value, you need the integral. You need integral, so these two integrals should be same. Okay, so by this way we know ey will be same with ex. There will be 4. 1 over 4. 4 over 3. 4 over 3. Okay, so EY is also this. And beside E, we also want the variance. The variance of x will be E of x squared minus EX squared. We know what is EX, right? It's 4 over 3. But what is EX squared? That will be integral of x squared times the density function of x dx from negative to positive infinite. And this is integral of x squared times, what is this one? Fx of x. We just have, that is 1/2 x, right? Dx. And the x need to run from 0 to 2. We don't need all the others. Okay, so this gives us 1/2 times x cubed. X cubed integral, we have x fourths over 4. And x run from 0 to 2. So this is 1 over 2 times 1 over 4, and 2 fourths minus 0 fourths. Okay, 0 fourths is 16. It's 4 times 4. So you see 4 times 4, you can cancel one of it, you have another 4 left. And divide by 2, you only have 2 left. So this is just 2. Am I good? Yeah, it is just 2. Okay. This is a variance of, oh no, sorry. I think it's too much. Yeah, need a minus EX. EX is 4 over 3 squared. Minus 4 over 3 squared. Minus 4 over 3 squared. And minus 4 over 3 squared. So this is 2 minus 16 over 9. It will be 9 of 18 minus 16, right? This is 2. That will be 18 over 9. And 16 over 9. So it's 2 over 9. So we have the variance. Variance is 2 over 9. Alright. And similar, we can have variance of y is also 2 over 9. Yeah, it's similar calculation. Just change x to be y. You replace all the y's here, all the x here by y, then you can have same result. That is a variance of y. Variance of y. Alright. Okay, this is a variance. And then we want to know the covariance. Covariance of x and y. For covariance, we also have a formula. It is E of x y minus E of x times E of y. Now we have this one, and we already have EX and EY, right? We have these EX and EY. Both are 4/3, right? They are 4 over 3. And then we should know what is EXY. EXY, because this is continuous type, right? So this is the integral of x and y times the density function fxy of x and y, then dx dy. Both x and y run from positive to negative infinite, negative to positive infinite. Then when you do calculate, you only need those non-zero value for this density function. So the integral will run from 0 to 2, 0 to 2. Then x is x, y is y. And the density is xy times k, which is 1/4. Alright. Okay. Then dx, dy. Now we do the calculate. This gives us 0 to 2. Here we do the integral. We have y squared over 2. We need to just move it out, right? Y squared over 2. They are independent with x, right? Not related with x. We only need integral for x. For x, we have x squared. So this is a x cubed over 3. dx, x squared. Yeah, okay, this one. This one from 0 to 2, and dy. This gives us integral of y squared over 4 times. This is 2 plus in, I get 8. 8 minus 0 cubed is 0 over 3 dy. So this is a 3/4 12. And y squared, we have y cubed over 3 when y run from 0 to 2. So this is 1/2 minus y is 2, I get 8. 8 over 3. 12 times 3, I'm sorry. 12 times 3 should be 36. 36. Right. And y cubed will be 8 minus 0. Right. This is a 8 over 36. It's how many? This is 4. This is 18. It's a 2 over 9. Okay, 2 over 9. 2 over 9. Okay, so we have EXY. Then we have covariance of x and y. There will be E of xy minus EX times EY. This is 2 over 9 minus EX is 4 over 3 and times EY is 4 over 3. So I think I got something wrong. This is independent, right? Independent, actually this should be 0. Okay, let's go now. K is 1/4, right? K is 1/4. K is 1/4. So this is 1/4. 1/4. Okay, I have this one. Then I move 1/4 y squared over 4. I put it here. Then x, I have x cubed over 3. And then I plug in y squared is y squared. The x squared will be x cubed will be 8 minus 0. Here's 4 and 3. Okay, these are the same thing. Then I have 12, or I have 8 here, sorry. I have 8 here. Then y squared, right? I move all the constant in the front. Then here's y squared. Y squared take integral, I get y cubed over 3. Then here will be 3 times 12, and numerator is 8. And then inside is y cubed minus, this 2 cubed minus 0. So 8 minus 0. Okay, now it's not this one. So this will be 8. Okay, I divide by 4. 4 9s is 36. This is 2. 2 8 is 16 over 9. Okay, we have this. This is the EX1. EX1. Then covariance will be 16 over 9 minus 4 over 3 times 4 over 3. That will be 16 over 9 minus 16 over 9. We get 0. Okay, this is correct. Yeah. So we have covariance of these two signals, x and y. This covariance is 0. Actually, here we have a general statement. We have a result. You can think this is 0. This should be a 0 in the textbook. X and y, they are independent. If they are independent, then we can claim that covariance of x and y, they are 0. Reverse side is not necessarily correct. That means we have some x and y. Covariance of x and y is 0, but they are dependent. Now we have that kind of signal, that kind of random variables. But this side is good. If they are independent, then the covariance of them should be 0. Okay, now we are done on this example. Okay, let's because when we when we solve this problem, I mentioned some result here, right? So let me Let me put the summary here. Yeah, we have this about the independent. So we have this f(x) of x times f(y) of y equal to f(x, y) of x, y, if only if x, y, they are independent. And secondly, this is for continuous case, right? For discrete time case, we have px of x times py of y. If this one equal to px, y, this is joint one. If we have these, then this related with this x, y, they are independent. Yeah, both conditions. This is for continuous type. This is for discrete type. And actually, we have one more. I didn't give that in the example, but it is not difficult. Actually, it looks similar with that. The third one, we have the CDF of x, the CDF of y. Actually, all of these, they are marginal distribution. Right? Marginal distribution. If we times these two equal to the density, the CDF of both x and y, if we have these, then we still have x and y, they are independent. Yeah, we have these three. Okay, what else do we have? Oh, we also have a formula. The covariance of x and y were equal to e of x, y minus ex times ey. Now we have this. Alright, so this example we are done, and we also have some rules. Maybe they will be helpful when you do some calculations. Okay. Now let's consider more examples. What kind of things can we have? Let's consider. Okay, we just use that model. We have. Suppose we have three colors. We have some balls with three colors: red, green, and blue. Okay, and totally 30 balls. 30 balls. We have red 10, and green also 10, blue also 10. Now each color we have 10 balls in a box. Then we pick one, then pick another one. Actually, we pick two. We pick two balls. Pick two. Then we have a kind of a distribution. Okay. We use x, the first bar. The first bar. And RGB, I use number 0, 1, 2 to represent. So the x is the first bar. The value should be 0, 1, or 2. Okay, three possible values. And the y, the second bar, the possible result is still 0, 1, 2. Right? And we check the probability. Okay, probability. Y is the second bar. Then what is the probability? Now suppose we do not put it back. We do not put it back. So if first time you pick one here, you pick one red bar, then there should be one third chance to get this red one, right? Then the second one, if you still have a red one, The second one won't be 1/3 chance. It will be, because you remove 1, so it will be 9/29, right? So this is 1/3. Right. The first bar is 1/3 possible. The second one will be 9/29. Now things like this. And when you have when you first bar is red, and the second bar you have green. Okay, the probability is the same. 1/3. This is for the red bar, and second factor, you have 10. You still have 10 green bar, right? Because the first time you pick a red, all the green and the blue bar that still keep there. And last one is also similar. 3 times 10/29. So this is first column. And second column, we have similar thing. The first bar, we have 1/3 possible to take this one, take this green bar. And now second bar is 0, is red, so this is a 10/29, right? Okay, the first bar is green, second bar is also green. Then this will be first bar is green, and second bar is also green, right? Make sense? Yeah, because we only have, we pick one, right? Pick one, then we only have 9 left. And this one is the first bar, we have 1/3 chance to get green, and then the second bar is blue. The probability will be this. Okay. And okay, the 1 here and 2 here. Well, x is 2, x is 2 here. X is 2. 2 means blue. When you have the first bar is blue, the second bar, the first bar is probably 1/3, and the second bar, the red, 0 is red, so it's still 10 red bars, right? This one. And the second will be 1/3 times, this is still 10/29. And last one, okay, so this will be different. This will be 1/3 times 9/29. Am I good? Okay. All right. So the result will be like this. Okay. And this time we want to see the marginal distribution. Marginal distribution. There will be summation of these 3. We put it here, and summation along this direction. We put it here. Okay. What are these? We do summation of these 3. 1/3 is still 1/3, and these 3 do summation, then the numerator will be 9, 10, 10 is 29, 29/29, so it's 1/3. It's 1/3. Okay, and the second bar, that is a green bar, right? The first bar you take green, then you have these 3 properties. You do summation. The first element is 1/3, and the times is 10, 9, 10/29. It's still 1, right? So just 1/3. And last one, similar, 1/3. You do summation, you have 1/3, and the numerator will be the other factors. They will be 10/29, 10/29, 9/29. So overall is 10 plus 10 plus 9/29. It's 29/29. This is 1 times 1. These will be the marginal density of x. We have this, the marginal. It's a marginal distribution of x. And this side we do similar thing. We do summation of these 3. Then we have 1/3 times 29/29. You got it? 9, 10, 10 is 29. Denominator is all 29, so this is 1/3. And the second row, we do summation of these 3. All of them have 1/3, and the times the fraction. You need to add these 3 fractions together. Denominator will be 29, and what is the numerator? summation of these three is still 29, right? Okay, this is 1/3. And the last one will be similar. You do summation along this way, you have 1/3 times 29 over 29, right? 20, 29. 20 plus 20 plus 9, that is 29. 29, right? 29 over 29, so this is also 1/3. Okay, so for this one we have the joint distributions here, and these are the marginal distribution, marginal PMF. And then I want to know whether they are stable, or whether they are independent. Whether X and Y, they are independent. Whether they are independent, you just check the marginal times the marginal. Can you have the joint distribution? Right? This column, there will be Fy of Y. Then you see, any two you times together, you will have 1/9, right? But here, none of them they are 1/9. Do we have? No, right? This is 1/9? No. Is this 1/9? No. None of them they are 1/9. So we say like this: because of Fy of Y times Fx of X equal to, it is just 1/3 times 1/3 equal to 1/9. Right? These do not equal to the joint density function, joint mass function, probability mass function. You cannot have 1/9. All of these, no 1/9, right? No. So they can't be equal. Right? Then we say X, Y, they are not independent. They are not independent. Yeah. Make sense? Yeah. Okay. This one, when you do summation, you have 1/3, but each one they are somehow kind of twisted, so you cannot realize them as a multiplication of these kind of things. Okay, and anything else can we have from this example? Yeah, actually we can do a lot of calculations, right? We can find the mean value, the variance value for both X and Y. We can have the covariance and the correlation of X and Y, right? And we can also calculate some probability if an event is given. Yeah, we can put like this. So, I will say. Okay, whether they are independent, this is just one question. Find the joint distribution, we already have. And then we can consider find EX, EY, variance of X, variance of Y, and covariance of X and Y. Yeah, try to find these. Then for EX, yeah, you check it. We have the distribution here, right? We have joint distribution here. For EX, you need the distribution of X. So this is P, sorry. It's a density function. I put the F. P. Density function, not density function, it's a mass function. So Px of X are these numbers. So Ex equal to summation of X times Fx of X for all X. And now X, only these three numbers. So the summation, just these three numbers times the value of X. They are 0, 1, and 2. So 0 times 1/3 plus 1 times 1/3 plus 2 times 1/3, and 2 times 1/3. Okay, so what is this? This is a 0, this is 1/3, second term, and last term is 2/3. It is 1. Okay, the mean value is 1. For x, we have 3 possible, the mean should be 1. And EY will be similar. There will be y times Fy, or P, Py of x, and for Rx. Okay. Then y could be value 0, 1, and 2. And the probability of each number is still 1/3, 1/3, 1/3. So it is 0 times 1/3 plus 1 times 1/3 plus 2 times 1/3. So this is 1/3 and 2/3. It is 1. It is 1. Still 1. It's EX and EY. EX and EY. And then the variance, it will be E of x squared minus EX squared. EX squared, you want to calculate x, right? You calculate x. X squared are these 3 squares, and the probability are here. So it is 0 squared plus 1 squared plus 2 squared. The probability are 1/3, because all of them they are 1/3, right? So I can put them together. 1/3, and minus EX. EX is 1, square of 1. All right. So this is 0 plus 1 plus 4, so it's 5. 5/3 minus 1 square. Okay, is 2/3. So we have variance of x, and the similar variance of y. There will be E of y squared minus EY squared. Similar thing, you will have 2/3. All right, symmetrically. Then covariance of x and y. This will be E of xy minus EX times EY. Okay, let me right here. Then EXY, you need the distribution here, right? Yeah. I write EXY will be the summation of all those x and y times the probability. Okay, we need this one, and for all x and y, all of x and y. And here you have a probability here, right? You have the mass function. The mass function, only for these 9 values they are non-zero. Otherwise, it is just 0. This one is 0, so we don't need them, right? You add some zeros, nothing. Okay, then we only consider both x and y run from 0 to 2. So this is 0 times 0, right? 0 times 0. Oh, that will be 0. Then times the probability, that is 1/3 times 9/29. This is first term. Okay, we have more. 0 times 0, 0 times 1, 0 times 3, and 1 times 0, 2 times 0. So all of these, 1, 2, 3, 4, 5, these 5 numbers, they need a times 0 in the calculation. And we only need these 4, they are non-zero, right? Okay, plus this one according to both x, y are 1. So 1 times 1/3 times 9/29. This is this element. And this element, x is 2, y is 1. So x is 2, y is 1. Times, this is also 1/3 times 9/29. 10/29. Yeah, this is 10 over 29. All right. And then this element, this is 2, that is 1. So this is plus 2 times 1. And then the probability over here, right? It is 1/3 times 10 over 29. All right. This is this one. And this one, now x, y, both are 2. So 2 times 2 times this probability is 1/3 times 9 over 29. Okay, so we have EXY here, somehow long. But yeah, just spend time. I get 1, 1, and these, I can cancel these 3. Okay, I just keep it. It's 9 over 3 times 29, the first term, the first non-zero term. And second non-zero term plus 2 over 20, right? 20. 2 times 10. Do I have this 10? Yeah, we have 10. So 2 times this 10, I have 20. And over 3 times 29. Okay, 3 times 29. And the third term, the denominator is still 3 times 29. And numerator now is 2 times 1 times 1 times 10 is 20. Okay, then next, I still have 3 times 29 in the denominator. And numerator is 4 times 4 times 9. So it's 4, 9, right? 36. Okay, we have this one, 36. Then result will be denominator is 3 times 29. And the numerator will be summation of these 4 terms. So I have these 2 is 40. 40 plus 30 is 70. 76 plus 9, so 85. Okay. It's a 40, 76, 49. 76, 89, 85. 76, 85. Yeah, 85. Can we do something, make it a symbol? Okay, it's not so easy. I just leave it here. All right. And then we want the covariance of x and y. This will be E of xy minus EX times EY. Okay, EXY we just have. This is 85 over 3 times 29. And the minus the mean. I have mean is 2/3, right? We have mean 2/3. Oh no, this is variance. Mean they are 1. Yeah, both means are 1. So minus 1 times 1. Yeah, both are 1. So this gives us how many? It's 85 minus 3 times 29. So this is 3 9 is 27. 2 3 is 6 plus 2 is 83. And here is 3 times, okay, 87. Yeah, like this. So this is a negative 2 over 87. We have the covariance. Here maybe people will say, okay, you calculate this kind of things where this should be positive. No, for covariance, they could be positive, could be negative. For variance, they must be positive. For covariance, maybe it's negative. Maybe they're negative. Okay. And this is also an example. We know these x, y, they are not independent. And the other side, the covariance is not 0. Because covariance equal to 0 is related with the independent of these two Van Raffles. Okay. So this is one example. And we have one more example. 45. I have 5 minutes. 5 minutes. Now we can do a small one. Okay. Example. I have a fx looks like this. X, y, they are random variables with joint PDF is fxy xy equal to value k or 0. Here if x positive, y positive, and x plus y smaller than 2, okay, 0. We try to find the k. Can we find this k? Okay, so this one, of course, you want to know what is sample space, right? Sample space, you give a graph here. This is x, this is y. For non-zero density, property density, we need x is positive. X is positive, this is this side, right? All these sides x positive. Negative. The other side is negative, x will be negative, right? And y is also positive. This is y positive, right? So the common area are here. Common area are here. So this is x positive, y positive. And also we have the summation smaller than 2. Summation smaller than 2, there will be a line like this. Here's a 2, here's a 2. This part. This part, it is x plus y smaller than 2. Smaller than 2. Okay. So we know the sample space will be things like this triangle. Okay, triangle. And then what is the k? To find the k, we need the integral of f(x, y, x, y) dx dy. We want this equal to 1. And this is constant. This is a k under this area. So then this one will equal to k times the area of that triangular, right? And this is what? This area is what? This side is 2, this side is 2. 2 is 4. So this rectangle is 4, and half of the rectangle, so it's 2. Okay? So this is equal to 2k. Then we can have k will be 1 over 2. That's it. Yeah. K is 1 over 2. Okay, that's the time. 48. Yeah. I don't have more time to do more examples. Then see you next time. Alright? That's all for today.